All right, gang, the mean of a normal distribution is unknown. However, it is known that the population standard deviation is 40, and a score of 250 represents the 80th percentile. Well, guys, this is going to be done exactly like the one we did previously in class, or previously in a video. Nothing new. So if you took good notes like you should have, this should be pretty simple. All right, so guys, we got this population up here. Of course, the mean is going to be in the center, but the mean is unknown. And the population standard deviation is 40. And we know that a score of 250 represents the 80th percentile. So a score of 250 has 80% of the scores below it. Now, we know that these raw scores can always be bounced off of z-scores, which has a mean equal to 0, standard deviation equal to 1. And this 250 has to have some z-score. So this 250 right here has to correspond to some z-score down here. And the obvious choice of the z-score that it corresponds to is the one that also has 80% below it. So gang, we can go over here in our calculator and do inverse norm. So we want area below 0.80, but we want this from the distribution of z-scores, which has a mean of 0, standard deviation of 1. So the z-score that's going to correspond to that is 0.84. So now putting everything together, we know that the z-score is x minus mu divided by sigma when we take things one at a time, which we're doing in this distribution. Doesn't say anything about a mean taking 50 at a time or whatever. It just says just the mean of a distribution of scores. So guys, we know the 0.84 is the z, so it's going to have to go right there. We know the score from the distribution is the 250. The mean of the distribution we don't know, so we'll just let it be mu. And we know that the standard deviation is given to be 40. So the first thing I would do is I would multiply both sides by 0.40, so I can do that over here. Now this 0.84 right here is that value right here. So I can just go multiply by 40, kind of cross multiply. And I know the number on the left is going to be 33.66. So I get the number contained in the calculator without rounding. Now, so what I'm left with now is, all right. So what I'm left with now is I'm left with the number that I have in my calculator, and on the left-hand side the right-hand side is 250 minus mu. So I know I need to subtract 250 from both sides. Just showing you how to keep a running number in your calculator. So now what I have is I have that new number in my calculator, and on the right-hand side I have minus mu. Well, it doesn't ask me to find the value for, it says what is the value of the mean. It doesn't say what is the value of the negative mean. But so all I have to do is multiply both sides by -1. So I get a mean of 216.34. Now, you're taking your test here in a few days, and you get that answer, and you're wondering, well, I wonder if it's right. Well, let's just try it out and see if it's reasonable, see if it's plausible. We know that a score of 250 represents the 80th percentile, so we're saying that the area below that, or to the left of that, when the mean is 216.34, 0.34, and the standard deviation is 40, we know the area to the left of that should be very close to 0.80. And we'll see it's 0.7999966, so that's very, very, very close to 0.80, and I would feel comfortable that I got that one right. When I walked out of the classroom, checking that, I would feel very comfortable that I got that one right. All right, gang, number 9, at a large grocery store, at a large grocery store chain that has stores across the country, 72% of its shoppers were found to be women. Now, when you see that 72%, what should you think? Central limit theorem? For proportions. Guys, this is getting into a situation where we have categorical data. Now, so right off the bat with this problem right here, number 8, before I even get started, I know that I'm dealing with a categorical variable. Why? Well, it's gender. You're either a woman or you're not a woman. Either a man. Well, I don't know. This Bruce Jenner stuff really kind of changed that. But I guess technically now Bruce Jenner is Caitlyn Jenner, a woman. So, but anyway, taking out that kind of situation. When this grocery store chain is looking at the gender of the person walking in the front door, it's pretty clear to determine that. So it's categorical, male or female, gender. And we know that these two are the guiding numbers of finding these values, okay? So part A says if n equal 40 shoppers are selected at random, then what is the probability? Gas probability starts with a P, so we know we're going to use normal CDF, that more than 75% of the shoppers are women. Now guys, remember this mu sub P is equal to the percentage that we start out with. So it's going to be 0.72 in this problem. The sigma sub P hat is the square root of P times 1 minus P over N. So for this problem, it's going to be 0.72 times, now 1 minus 0.72, I can see that that's 0.28. But let's say that some of you can't. That's not a big deal. Just use your calculator and type in 1 minus 0.72, and then just put that number right there. And then you divide out by the sample size, which we can see in this case is 40. So that's going to be the standard error. All right. So I can go ahead and do the square root 0.72 times 0.28 divided by 40. Don't close that parentheses up until you get all the numbers in there. So 0.0710 would be the standard error. So that's the standard error. So gang, now we're ready to work the problem, right? So if n equals 40, what's more than 75? So more than 75 tells me that I start with the number. So again, never use percentage in math. If you do, you look stupid. In this case, it would give you an error. Now, gang, you could just type the 0.0710 there. I don't see any reason to do that. I would just go ahead and just type it out. And again, don't do that. So many times I see students that want to close that parentheses up too soon, and when they do that, they just screw up and get the wrong answer. They're like, well, I don't know what I'm doing. Well, actually, you do know what you're doing. You just got sloppy. So the answer is 0.3363. All right. Next problem. A sample of n equal 250 women are selected at random. That should be is selected at random. And 175 are women. Calculate and interpret the z-score for the sample. Now the z-score for these types of problems is harder. But it sets the stage for some of the stuff we're going to be doing later. So the z-score looks like this. So what we got to do first of all is we got to find p hat. And guys, remember, p hat is just x over n, and x is the count out of the whole that have the characteristic that we're measuring. In this case, it's a woman. So of our sample of 250, what was the count out of the whole that had the characteristic, in other words, gender being a woman? 175. So I'm going to put 175 divided by 250 in my calculator, and I see that I get 0.70. So gang, I know when I work this problem that my p hat that comes from my sample of 250 women, p hat goes with your sample, p goes with your population. Your p hat is 0.70. P doesn't change, it's given to you in the problem. Guys, again, order of operations, make sure that's in parentheses. And the bottom doesn't change either. The only thing that will change here is our sample size is what? 250. So if we can put that in our calculator without doing something goofy, we're going to get this correct. So 0.7 minus 0.72 divided by the square root 0.72 times 0.28 divided by 250. I've had students before that have wanted to put the 175 there. And say, well, that's a number. Yeah, but it's the wrong one. You want the sample size 250. 175 was the count how many women out of the 250 there were as shoppers. So let's hit enter, and I get a negative 0.70. Now I'm going to write this interpretation out. So we would say a sample proportion of 175 out of 250 is 0.70. Guys, when we always use the absolute value of that, we don't include the negative or the positive. Just include the positive because this is negative, we'll use below, okay? So that'll come later. So it's 0.70 standard errors. Below, this is the part that comes from the negative. Below the mean. So guys, that would be the interpretation of the z-score. So our z-score here is going to be negative 0.70, and then the interpretation is the other way. All right, gang, number C. Isn't it comforting that your statistics professor doesn't know a number from a letter? What sample proportion represents the first quartile? You guys, first quartile has what percentage below it? 25%. So we're asking what score from a distribution. So I'm going to go second function distribution, inverse norm. I need 0.25 to the left. I have a mean of, now this is a little bit, this question's really, this question should include a sample size. And what I meant is to use the sample size from the previous question, but when you read this, it's not clear. The way this is written, what sample proportion represents the first quartile can't even be answered unless I provide a sample size. So I meant 250, but again, it's not clear, but I will be clear on the exam. So the mean is 0.72. And remember the standard error, you've got to have the sample size. So 0.72 times 0.28 divided by the sample size. This is why we got to have the sample size to work this problem. It may give me an error. No, it doesn't. So the sample proportion that represents that is 0.70. All right, gang, what measure of center would be preferred to describe the following 5 salaries at a small corporation? Now, this is a little bit tricky because typically you think about anytime you deal with numbers, I'm sorry, not numbers. Anytime you deal with dollars, you're going to have a positively skewed distribution, so you'd need the median. But sometimes at corporations or in small neighborhoods, people tend to have the same economic value, right? If you go to a really fancy schmancy neighborhood in Miami, Florida, then you're going to have houses typically of the same value. But if you look at house prices all across Miami and allow for variability, then you're definitely going to get into a positively skewed distribution. So what I would do here is I would just go ahead and play the game. And I'm going to go over here and clear this out. So hit clear enter, and I'm just going to type these numbers in. So I have 15,000, 18,000, 20,000. And you can kind of see what's going to happen here. Well, I can because I made up the problem. But you can too. You can see that these 4 numbers are pretty clustered, pretty close together. But then we got somebody, maybe the boss's son or daughter, making 150,000. So that's clearly going to be an outlier. But nevertheless, let's go through the game and let's turn this on. Let's get a histogram for L1 frequency 1. All right, so go zoom 9. All right, now I'm glad this happened. This is a situation that when I came down here and hit 1, there was something that jumped up at the bottom. This type of calculator, for you to be able to graph, you've got to go back up to the top before you hit zoom 9. Now when you get that, you see we get a positively skewed distribution. So again, with a positively skewed distribution, we would use the median. All right, this next problem is going to drive me crazy because I'm going to have to do some typing, but so will you. So 0, I'll yellow them out, so type along with me, hopefully. 40, 72. Now, I didn't get rid of the numbers before because I know I've got more numbers that I'm going to enter than I had in L1, so I know I'm going to have room to type over. Where you get in a problem if you don't delete your data, let's say you've got a previous problem where you had 25 numbers, and then the next problem you have 20. Well, if you don't clear it out, sometimes it's easy to forget those 5 at the bottom. And if you leave those included, obviously, you're not going to get the right answer. Hopefully I'm seeing this correctly. 239. This is boring. 267, 310, 505, 742, 837. It's kind of looking like to me, 1034, that we've got a positively skewed distribution, but actually, it's kind of, I don't know. I even made the problem up. 1286 and 3000. Actually, it looks the other way now that I look at all the numbers. All right, what is the shape of the distribution? Well, guys, to do that, you're going to want to go to the histogram. So again, I'll come down, get L1, and then, guys, I can't hit zoom 9. If I do, that's going to happen, and that's not cool. So what I do, I've got to go second function quit to get out of that, which is very, but let me show you how you can keep that from ever happening. When you get down to the bottom and you put everything in, if you'll just scroll back up to the top before you hit zoom 9, then that won't happen. All right. So guys, we clearly have a now that those lines going through there, that's just some junk that I had from teaching another class. Well, it's not junk. It's actually kind of cool stuff. But I can get rid of that just by eliminating those two functions. So guys, I clearly have a positively skewed distribution because the tail goes to the right. So what is the mean and the standard deviation? Well, I'm going to use my calculator. So I want my numbers in L1, but guys, my frequency list, I want that deleted. I don't want a frequency list. All my numbers are in one list. So I leave that blank when I have a frequency list, when I don't have a frequency list. So my mean is 557.81. And the standard deviation is 756.09. Now you should know by now that use the SX and not the sigma X. Okay. Are there outliers? Well, guys, to determine outliers, we got to do a box plot. So come down, select it. Everything else is cool, so let's go zoom 9. And it turns out we do have an outlier. We have one here. Now let me show you how to find that. If you go up here and do trace, what happens is kind of cool. And hit your right arrow, it'll run through and it'll show you the first quartile. It'll tell you the value of the median. It'll tell you Q3. It'll tell you the biggest number in the data set that's not yet an outlier because it's still attached to the main frame of the box plot. And then we'll come on up to this one, which is 3,000. So are there outliers? Yes. There is one outlier, and its value is 3,000. All right, gang, number 12. It's the last problem. Darn. I think it's the last problem. Yeah, it is the last problem. Okay, since in 1900, the magnitude of earthquakes in California that measured 0.1 or higher on the Richter scale is normally distributed with a mean 6.2, standard deviation 0.5. This data was obtained through the United States Geological Survey. So we have a normal distribution. Well, we have a distribution, I should say, that's approximately normal. With a mean of 6.2 and a standard deviation 0.5. So sometimes that's the way we write that. So what percentage of randomly selected earthquakes in California during this time period has a magnitude 5.8, 7.1? Guys, this is an easy problem. Hit second function, quit. Get out of the previous problem. Go to distribution. Use normal CDF. So we want between 5.8 7.1, so in these situations you don't have to worry about any E99 or negative E99. Mean is 6.2 and standard deviation is 0.5. Don't have to divide out by sample size because it doesn't say anything about percentage or probability of a mean or average. This guy's answer 0.7522. Find and interpret the z-score for an earthquake of magnitude 3.2. Again, the z-score formula one at a time. We take the score minus the mean over the standard deviation. Put the numerator in parentheses. So we get -6, which tells me that an earthquake of magnitude 3.2 is 6 standard deviations below the mean. Now the final question, what's percentile ranking? Guys, remember percentile ranking is just percent below. Talked about that in previous videos. So ultimately, what is this saying? What is the percentile ranking of an earthquake with magnitude 7.5? This is equivalent to saying what percentage of earthquakes is below 7.5. Use the same key. So we went below, so we start with negative E99. Now, let me bring this up. A lot of times people have problems with this negative E99. Remember your lower bound right there. Let's think this through. Your distribution, normal distribution, goes from negative infinity to positive infinity. This is the extreme lower bound. This is the extreme upper bound. Now, sometimes I see people put positive E99 for the lower. The lower is the number to the left. How can the biggest number ever be over here? This is the symbol for the biggest number ever. It's infinity. It can only go in the upper, and this is when we have keywords like above, greater than, to the right of, something like that, okay? Then I see a lot of students who put the negative E99 in the upper. How can this be right of anything? It can't be right of anything. It's the lowest number possible. So, guys, this number right here can never be in the above or the upper entry. And this number right here can never be in the lower. This says there's something to the right of it. Well, it can't be anything right at the biggest. This says if you put this in the upper, it says there's something to the left of it. Well, how can the lowest number have anything to the left of it? And again, it's a symbol, it's not a number, but nevertheless. So negative E99 can only go in the lower, and positive E99 can only go in the upper. Now, you can't switch that way. I mean, you can switch them, but you're going to get them wrong. So what is the percentile ranking of 7.5? So we got our mean, our standard deviation. So again, we want percent below. So we would say that this would be the 99.5th percentile. So 99.5% of the earthquakes are at or below a 7.5. Of course, that's kind of reasonable because a 7.5 earthquake is that's a pretty big guy. It's pretty you're doing a whole lot of shaking when you get something like that. All right, gang, that's it. These are going to be really good problems to understand how to do on your midterm. So, guys, take care.